Let's take a look at total utility and marginal utility with two products. Indifference curves show the combinations of the quantities of two products that give a consumer the same amount of total utility. Here on the left, on the vertical axis, we have the quantity of apples, and on the horizontal axis, we have the quantity of tennis balls. We can see the three indifference curves. Now, the total utility on IC1 is less than the total utility on IC2, which is less than the total utility on IC3. The total utility at point A on IC1 is less than the total utility at points B or at point C on IC2. The total utility at point B on IC2 equals the total utility at point C on IC2. Along the indifference curve, there is equal total utility. The different points represent a different combination of the quantity of apples and the quantity of tennis balls. At point B, there is a greater quantity of apples, but at point C, there is a greater quantity of tennis balls. Regardless of the combination, the total utility remains the same. And lastly, the total utility at point D on IC3 is greater than the total utility at points B or at point C on IC2. As the indifference curve moves further away from the origin, the total utility along that curve increases. We're going to take a look at consumer behavior. Remember that the objective of a consumer is to maximize total utility, but they must consider their constraint, which is income. And we're going to focus on income. First, let's take a look at the income or budget constraint equation. Income equals the price of X times the quantity of X plus the price of Y times the quantity of Y. Below you can see the mathematical equation. I for income equals Px, the price of X, times X, the quantity of X, plus Py, the price of Y, times Y, the quantity of Y. And below we can see the income/budget constraint line, this downward sloping line. On the vertical axis, we have the quantity of Y, and on the horizontal axis, we have the quantity of X. Let's take a look at some important points of the income or budget constraint line. First, the vertical axis intercept, represented by I over Py, represents the maximum quantity of product Y that can be purchased. That means that none of X is purchased. On the other hand, the horizontal axis intercept, represented by I over Px, shows the maximum quantity of product X that can be purchased. That means that none of Y is purchased. If we take a look at point A, which falls inside of the income/budget constraint line, that means that not all of the income is spent on X and Y. We have some money left over, and that is considered savings. If we look at point B, which falls on the income/budget constraint line, all of the income is spent on X and Y. We have zero savings. And finally, if we look at point C, which falls outside of the income/budget constraint line, this is an unaffordable combination of X and Y because it falls outside of our income/budget constraint line. Let's take a look at some shifts or pivots in the budget constraint line. Let's take a look at our first example. From BC1 to BC2, represented by the blue arrow, the budget constraint/income line shifts to the left. This represents a decrease in income. On the other hand, represented by the red arrow, the budget constraint/income line shifts to the right, from BC1 to BC3. This represents an increase in income. Now let's take a look at the second example. From BC1 to BC2, the budget constraint/income line pivots to the left. This is representative of the price of product Y increases, while income and the price of product X stay the same. From BC1 to BC3, the budget constraint slash income line pivots to the right. This means that the price of product X decreases, while income and the price of product Y stay the same. Now let's take a look at consumer behavior. We're going to consider both the objective to maximize total utility and the constraint of income. This brings us to equilibrium. Equilibrium is when total utility is maximized, when the combination of the quantity of X, represented by X star, and the quantity of Y, represented by Y star, is consumed. Equilibrium is found where the indifference curve, in our example, it's red, has a tangency point with the budget constraint slash income line, in our example, the blue line. We can see at this point we have a combination of X and Y represented by X star and Y star. And this is the combination of X and Y that maximizes the consumer's total utility. Now we're going to take a look at consumer behavior again, considering both the objective to maximize total utility and the constraint of income. By using the Lagrangian method, we can find the quantities of the product that maximize consumers' total utility. We can see from the Lagrangian method that total utility is maximized when the marginal utility per dollar spent one product, MUX over PX, is equal to the marginal utility per dollar spent on the other product, MUY over PY. Thank you for watching. Please like and subscribe.